and instead do this paper, which is your this is May June 2020. Have you done this paper?
No, sir.
So we're going to try and do this paper. Give the name of the process that turns occurs when a gas. What is this called? Gas turns into a liquid. What is the name given to it? Quickly, it's a very easy question. Gas to liquid. Okay, so this is known as condensation. Then you have occurs when solid turns into a gas without first forming a liquid. Solid turning directly into a gas. What is that called?
Sublimation.
Yes. So that is sublimation. Then you have is used to prepare a mixture of liquids. Is used to separate a mixture of liquids with how do you separate a mixture of liquids with different boiling points?
Fractional distillation.
Okay, that one is fractional distillation. Uh, then you have what is the process known as is used to extract aluminium from aluminium oxide?
Electrolysis.
Okay, that is electrolysis. Is used to separate a mixture of amino acids.
Chromatography.
Okay, that is chromatography. And the next one, you're given the symbols of the elements in period 2 of the periodic table are shown. Group 1, group 2, 3, 4, 5, 6, 7. Okay, so order mein. For each of the following, give the symbol of an element from period 2 which matches the description. Combines with hydrogen to produce ammonia. So which of the elements, what is the formula for?
Nitrogen.
Okay, so that's obviously nitrogen. Makes up approximately 21% of clean dry air.
Oxygen.
Oxygen.
Okay, oxygen gas has atoms with only 2 electrons in the outer shell. So who has 2 electrons in its outer shell? By which group? 2 valence electrons. ये तो आसान है.
Beryllium.
हाँ, तो मतलब it's going to be beryllium. ठीक है, मैंने कहा था कि order में. This is group 1, this is group 2, 3, 4. So this is beryllium. Next one is has atoms with only 7 protons. तो ये तो खैर periodic table देखना पड़ेगा. बल्कि I'll write this down. This is 3. Periodic table में it's
Nitrogen.
ठीक है, that would be nitrogen. Which one is a monatomic gas? Yeah, which elements are monatomic? That don't combine with anything. Monatomic का मतलब है they exist as single atoms.
Neon.
ठीक है, so that is a noble gas. Noble gases are all monatomic. It's a soft metal stored in oil. Which metals are soft?
Group 1.
ठीक है, so this one would be lithium. ठीक है, so this is done. Dotted cross diagrams. He's saying the magnesium reacts with fluorine to form the ionic compound magnesium fluoride. The electronic structures of an atom of magnesium and an atom of fluorine are shown. So you have to draw the structure, complete the structure. So how many electrons would be lost by magnesium? Well, it has a total of 2 valence electrons, right? So the inner shell would be full, but the outer shell would be lost. So it will have a charge of 2 plus, and fluorine, on the other hand, would gain how many electrons? There's only room for 1 electron. So fluorine, well, सारे dots हैं. So fluorine would gain 1 electron. It will have a charge of -1. The diagram is still incomplete. What should I do?
Add a 2 outside the bracket of fluorine.
Okay, there should be 2 fluorines because it's only gaining 1 electron and it should be gaining 2 electrons. So there should be 2 fluorine atoms. And the formula of magnesium fluoride would be that's obvious. Mg, there's 1 Mg and there's 2 fluorines. Magnesium fluoride does not conduct electricity when it is solid. What can be done to solid magnesium fluoride to make it conduct electricity? In your answer, explain why magnesium fluoride conducts electricity when this change is made. So it's an ionic compound, right? Ionic compound is a bunch of positive ions negative ions, positive ions, negative ions, they're all attracting each other, right? I mean, there's going to be forces of attraction, oppositely charged ions, and the ions cannot move around. So when do ionic compounds, I mean, this is an ionic lattice. When do ionic compounds conduct electricity?
In molten form.
Okay, so you need to convert them into a molten state. And why would they conduct electricity in molten state?
They have free electrons.
They don't have free electrons, they're ions. I mean, they have charges, but in molten state, the ions or the charges would be able to move around. So they would be free moving ions. Okay, remember, electricity is conducted in ionic compound. If you remember electrolysis, the ions are the ones that are moving around. I mean, they're going to cathode, they're going to anode. So electricity in an ionic compound, electricity is conducted by ions. Electrons are used in metals. In metals, they have delocalized electrons, so they are conducting electricity in metals and graphite as well. So they have free moving ions. As the next one, everything is given. There's a single bond over here, so that means one electron would be shared, a single bond over here, one electron would be shared, and there's a double bond over here. That means they're going to share two electrons. And I'm going to use a different symbol for oxygen's electrons. Now, the dotted cross is complete except for the fact that you have to draw the leftover electrons. Fluorine in total had 7 electrons. So it shares 1. So that means 6 electrons are still present. And for this as well, there would be 6 electrons that would be present. Oxygen had a total of 6 electrons. It shared 2. So you've got 4 electrons left. The next part is the melting point of magnesium fluoride and carbonyl fluoride are shown. So this is a covalent molecule. Covalent molecules have low melting and boiling points. Why do they have low melting and boiling points? Because when you have a covalent molecule, like if you have these two, you have one CF2 molecule and you have another COF2 molecule, then they don't interact with each other. They don't have a bond between them. Only weak intermolecular forces. This is so they're separate molecules, separate individual molecules, and they're mostly gases. Like no one would be stopping this molecule from moving around. So all these molecules, they would be just randomly traveling in different directions. In the ionic lattice, the ions were stuck in place. They can't move because everyone is attracting everyone else. So you can't have movement over there. But in simple molecular structures, the melting and boiling points are very low. So explain using knowledge and structure of bonding why magnesium fluoride has a high melting point. Uh, so that's ionic. So you're going to write that there's going to be giant ionic. They're going to form a giant ionic lattice, and positive and negative ions have strong electrostatic force of attraction. Which would prevent them. I mean, has a strong electrostatic force of attraction. So we have to actually explain why they have a very high melting point. So large amount of energy is needed to break the ionic bond. Mahad, is this clear?
Yes, sir.
The next part is explain using knowledge of structure and bonding why it has a low melting point. So the first thing is you're going to write that they have a simple molecular structure. So molecules of COF2 have weak intermolecular forces. I mean, the molecules are independent, they don't have any charges. So one molecule has nothing to do with the other molecule. There are no charge, they're not charged particles, they don't attract each other. So molecules CF2 have weak intermolecular forces, which can which don't need or large amounts of energy to be broken. Anyways, moving to the next part of the question, this is about, I think, sulfuric acid. This is about the contact process that we recently did. How is sulfur converted into sulfur dioxide? This was that molten sulfur was burnt and write an equation. So you always write an equation. This was contact process where you had oleum, etc. Describe how sulfur dioxide is converted into sulfur. Now you have sulfur dioxide formed. So the next part was that you had to write the next step, which was that sulfur dioxide was reacted with sulfur with oxygen, and they ended up producing sulfur trioxide. This should be 3. And the conditions for this reaction were that the temperature that was required was 450 degrees centigrade, and the pressure that was required was 1 to 3 atmospheres, not a very high pressure. And the last part was that the catalyst that's needed for this is vanadium pentoxide or V2O5. ठीक है, ये थोड़ा थोड़ा याद है? Sidra, do you remember this? Ahmed?
Yes.
So what is meant by the term equilibrium? Simply means the rate of forward reaction and the rate of backward reaction is equal. Equals the rate of backward reaction in a reversible reaction. अच्छा पता नहीं what happened. As the next part was sulfur trioxide is converted into H2SO7. So what you did next was that instead of dissolving it in water, because it would be an explosive reaction, this SO3 was dissolved in concentrated sulfuric acid to form oleum, which was H2S2O7. And in the last step, the oleum was converted into sulfuric acid, so that H2S2O7 was then diluted by adding water. So it's H2S2O7. You dilute it with water, and you're going to get 2 molecules of sulfuric acid. So that was how this is the entire contact process. Now this one was that you have to balance the chemical equation, whatever the reaction that's happening over here. So there are 2 sulfurs over here. So I'm going to add 2 over here, and there would be 4 hydrogens. So there should be 2 H2O molecules. And you can count the number of oxygens. That's 8. Over here, that's 4 plus 2, 6. 6 plus 2, that's 8. So I think pretty much everything is balanced. Now the question is, sulfur dioxide is a reducing agent. Give the color change that occurs when excess sulfur dioxide is bubbled into acidified potassium magnate 7 solution. Now, I had previously told in redox that you have to remember the color change that happens. Uh, let me open the data sheet as well quickly. So here's the data sheet on your screen. And in this data sheet, I had written that you have to memorize everything, and there was a specific thing that has to be memorized, and that's about oxidizing and reducing agents. Remember, potassium magnate KMNO4 is a purple colored oxidizing agent. It's a strong oxidizing agent. You must remember these 2 oxidizing agents. This potassium dichromate 6 and this potassium magnate 7. And it is purple in color and turns colorless when reduced. So this is what would happen over here. That starting color of the solution would be purple. You have to remember KMNO4. Okay, this is K-4, and it would change to colorless. It's an oxidizing agent, O.A, and it's reacting with a reducing agent. Oxidizing agents react with reducing agents. So this is what's going to happen. Then the question is, when sulfuric acid reacts with ammonia, the salt ammonium sulfate is produced. Everything is given already. So it's sulfuric acid, which is H2SO4. We just have to come up with an equation. The next is ammonia, which is NH3. And the product has ammonium sulfate, which is NH4 plus 1 and SO4 minus 2. And you need to balance this, so there should be 2 NH3. The next part is barium sulfate is an या तो clear है सालों को? Is this clear? Ahmed, is this clear? Saad? वो नहीं है मेरे ख्याल से. Sidra, is this clear? Iram?
Yes.
अच्छा, so next part is barium sulfate is an insoluble salt. Barium sulfate can be made when from aqueous ammonium sulfate using a precipitation reaction. Name a solution that could be added and write an ionic equation. तो मैं थोड़ा सा barium sulfate, insoluble salts. What was the method of preparing insoluble salts? Barium sulfate. ठीक है, remember the solubility table. ठीक है. So how do you make this salt? I told you insoluble salts are prepared by ionic precipitation, which they are discussing the precipitation method. Now, in the precipitation method, you're going to take two compounds and mix them. You're going to take a barium compound. So one of the ions is going to come from barium ions. The other one should come from a soluble. They should be soluble. So in this case, he's using ammonium sulfate, NH42SO4. But I'm not even interested in ammonium. I'm just interested in a compound that contains sulfate ions. So this is aqueous, and I need a soluble barium salt, barium compound as well. So I'm just going to use nitrate. All nitrates are soluble, so that's an easy choice. So this is also aqueous. So in precipitation, what happens is that you need to make an insoluble salt, you're going to choose two soluble reactants. One of them must contain one of the ions, the other one must contain the other ion. And when they are aqueous, what happens in aqueous state is that if you pour them in a mixture, in a beaker, you add this and you add this. Because they're aqueous, the ions would scatter. Barium ions and nitrate ions would all scatter in the solution. Ammonium ion and sulfate ions would also scatter in the solution. Now, when you mix them together, if barium and sulfate ions combine, they would form a precipitate at the bottom because barium and sulfate, if they combine, they don't dissociate again. They form a very strong bond. It's an insoluble salt. So your solution would, the quantity of sulfate ions and barium ions would decrease. And what would be left in the solution would be ammonium nitrate. It's not going to form a precipitate because it's very, very soluble. So what's left in the solution would be ammonium nitrate and in aqueous state. And what you're going to do is you're going to filter this off and wash this salt with distilled water. Okay, so this is precipitation. And you're going to carefully choose your so you're going to carefully choose your two compounds. They could have been anything as long as this one contains sulfate and as long as this one contains barium and as long as both of them are soluble. It could have been barium nitrate. Barium chloride is also soluble. Some other compounds of barium might also be soluble. Barium hydroxide is soluble. And this one has to be a sulfate. It could have been any sulfate. It could be sodium sulfate, potassium sulfate, any sulfate. That's most sulfates are actually soluble. So MgSO4, that's also soluble. ये clear है? Mahad, is this clear? Ionic precipitation, the salt preparation method.
Yes, sir.
I said, anyways, Iram, is this clear?
Yes.
Anyways, the other thing that they had wanted us to do was they wanted us to write an ionic equation. How do you write an ionic equation? If this is my equation, उससे पहले क्या पाऊंगा था वैसे? The first में तो सिर्फ name a solution that can be added. So I wrote barium nitrate. Now, how do you make ionic equation? Ionic equation, if there's a substance that is aqueous, you dissociate it. Let's first check this has to be balanced, I think. So this is going to be written in dissociated form. So it would be barium ions and two nitrate ions because they are aqueous, so those ions would get scattered. Ammonium sulfate is also aqueous, so there would be two ammonium ions and a sulfate ion, and the product is going to be BaSO4 is solid, so they're not going to dissociate. And ammonium nitrate is also aqueous, so that means all its ions are going to be scattered in the solution. Now remove the spectator ions. The spectator ions are ammonium ions, they're not doing anything. Nitrate ions, they're not doing anything. So basically, at the end of the reaction, what's actually happening is barium ions and sulfate ions are getting together to form BaSO4, which is clearly obvious that barium and sulfate ions are linking up to form this precipitate of BaSO4. Ammonium ions and nitrate ions are not doing anything. Okay. Let's move to the next part of the question, which is catalyst. What does a catalyst do? So a catalyst speeds up the reaction. And how does it do that? By reducing activation energy. By reducing activation energy, that's it. That's pretty much it. That's all. Uh, remember when we were talking about rate of reaction, हमने पढ़ा था कि whenever you have to do a reaction, for example, this N2 molecule is in air and you have your O double oxygen molecules in air, they don't react with each other. The reason is that it's very hard to break the triple bond. So these bonds are very strong. So unless you break those bonds, a reaction or a new compound would not be formed. Like if you want to combine nitrogen with oxygen, you have to get rid of this triple bond first. And you have to get rid of the double bond first. So this is where the catalyst helps. It helps us in breaking these bonds. It makes the collisions more effective. Remember, I told you two things that there was when you talk about the speed of a reaction, you talk about the frequency of collisions, like how many times are they colliding per second. And you also talk about the effectiveness of collisions. So, for example, if you have 100 collisions, so how many of them were effective? How many were successful? So, the two molecules might collide with each other very frequently. But if the bonds are not breaking, no reaction would happen and 0% of the collisions would be effective. So, you need both things to be high. You need more frequent collisions as well as you need more effective collisions as well. Now, the next part is probably a rate of reaction question. The student measures the volume of oxygen produced at regular time intervals using the apparatus shown. Uh, so, large lumps of, whatever is happening, there's a reaction going on, and he's calculating the volume of oxygen produced. और हर ग्राफ इसी तरह होता है स्टार्ट के अंदर ऑक्सीजन gets produced at a very fast rate. I told you in rate of reaction that if your graph is steep, that means oxygen gas is being produced at a very high speed. Like there's lesser time, it's going up. Lots of oxygen gas being produced. So the reaction is very fast. And if your graph becomes flat, that means the reaction has stopped. So the gradient is zero and the speed is zero. Gradient basically gives you an idea of what is the rate of the reaction. So what happens to the rate of this reaction as time increases? In your answer, explain why the rate changes in this way. Now it's a kind of a very large question. So we're going to talk about everything because it's 4 marks. So I don't want to miss out on any of the marks. The first thing is you're going to write rate decreases as time increases. So you're also going to explain how did you figure that out? Because gradient of the graph it decreases and eventually becoming zero. So it eventually becomes completely zero. Okay, so eventually becomes zero. Uh, then we can also write why is this happening? Because your reactants they get used up as the reaction proceeds. Reactants get used up. Like if you burn a match, why does the match burn at a slower speed after some time and eventually it kind of dies down? The reason is because after 10 seconds there is no match because all of the reactants have gotten used up. The matchstick would be burnt completely. So reactants get used up and their concentration decreases. And when that decreases, you have less frequent and effective collisions. Like if the concentration is lesser, they're not going to be bumping into each other. So less frequent and not effective. I mean, you just have less frequent collisions. Effectiveness of collisions can only increase with the presence of a catalyst or if you increase temperature. Is this answer clear to everyone? Mahad, is this clear? Ahmed, clear?
Yes, sir.
So the experiment is repeated using the same mass of magnesium 4 oxide. Powdered magnesium oxide is used instead of large lumps. So if you're using powdered, the reaction is obviously faster. Sketch a graph on the, so all other conditions stay the same. Sketch a graph to show how the volume of oxygen changes with time. So if you're using powdered manganese catalyst, the speed of the reaction is going to be faster. So not exactly like this. I mean, the gradient is eventually the same mass of oxygen gas will be produced, but it's going to be steeper. It's going to be steeper, it's going to be faster. The next part of the question is, in terms of particle, explain what happens to the rate of the reaction when the temperature is increased. So what happens if you increase temperature, then what happens? Kinetic energy increases. So you have more frequent collisions and you also have more effective collisions. That's it. So if the kinetic energy of the particles are traveling faster, that means the particles would be bumping into each other more, so there would be more frequent collisions. Plus, they have more energy, so you're going to have more energetic collisions. So the collisions would be more successful. Okay, is this clear? Iram, is this clear?
Yes.
I said then you have the equation for the decomposition of hydrogen peroxide is shown. It's a moles question. 25 cm cube of hydrogen peroxide forms 48 cm cube of oxygen gas. So 48 cm cube of oxygen gas. So I can find moles. How do you find moles of what was the formula of moles? Moles was volume of gas. And for gases, it was divided by 24 dm cube. So we are going to do just that. So it's going to be 48 cm cube. In dm cube, it would be 0.048. So if I take out my calculator, so it's 48. It gives me 0.0002 moles. What about Now you're being asked to calculate the concentration of H2O2. Now you have the moles of O2. Based on that, you can find the moles of H2O2. It's going to be double that because the ratio is 2:1. So I told you that if you find the moles of one substance, you can find the moles of pretty much all the other substances. So the moles according to this ratio would be 0.004 moles. The volume is already provided for hydrogen peroxide. So that's given as what, 25 cm cube. So how do you figure out? I mean, we did the first two. I mean, how do you figure out this thing, concentration? You have the volume, you have the moles. So concentration is moles over volume, which in this case is 0.004 moles divided by 25 cm cube, but that would be in dm cube. So it's going to be 10 power minus 3. This is the answer to the third part actually, and you can solve this. Is this clear? Sidra, is this clear? Mahat, clear?
Yes.
Yes, sir.
So again, I've pressed the wrong key. So the next part is what is meant by the term electrolysis. So it's the decomposition of an electrolyte by passing current. So I'm going to check the marking scheme as well on this one because it's a 2-mark question. Usually it's not a 2-mark question. So let's check out the distribution of the marks for this question. So did we get both things right or not? So this is question number what? Question number 5. So if I go to question number 5, I'm going to get I'm going to get I mean, this is not question number 5. So it is breakdown or decomposition of an ionic compound in molten or in aqueous solution uh, using electricity. So I think we had to describe our electrolyte. So that was one weakness in our answer. The only thing that was it was electrolyte. We had to tell them what the electrolyte was. So it was an ionic compound in molten and aqueous state. So that you have free moving ions. That was the only thing. Uh, as a name a substance that could be used for inert electrodes. What are the two substances that are used?
Platinum.
Okay, so there's platinum and carbon. Okay, both would be correct, right? An ionic half equation for the formation of hydrogen during this electrolysis. During what electrolysis? I said it's electrolysis of concentrated NaCl. So we can quickly do electrolysis of concentrated NaCl. You're going to have a beaker. There's going to be cathode and there's going to be anode, and there's going to be electrons coming in from this side, going back to this side. This is the negative side. This is the positive side. Now NaCl is Na plus 1 would be over here and Cl minus 1 would be over here, and there would be two more ions. There's going to be H plus 1 and OH minus 1. And he's already told you that inert electrodes, chlorine is formed and hydrogen is formed. So at this point, chlorine would be formed. Chlorine is diatomic, it would lose electrons, and it's going to form Cl2. On this side, hydrogen gas is formed. They've already told us. That's also diatomic, so it's going to be 2 electrons, and it would form H2 gas. So you're going to get your two reactions at anode and cathode. You don't even have to think. They've already told you what's going to be formed. So we've written the ionic half equation. Give the formula of the 4 ions present in concentrated NaCl. So Na plus Cl minus 1, H plus and OH minus 1. Okay, let me double check what are the other. ठीक है, that's pretty much it. Explain how sodium hydroxide is formed during this electrolysis. So if you go back and have a look at the electrolysis, H plus 1 is gone, Cl minus 1 are gone. So what's left behind? It's NaOH. So when H plus 1 and Cl minus 1 are discharged, and Cl minus 1 are discharged, and the solution then contains Na plus 1 and OH ions. अच्छा ये सारा क्लियर है? Bahad, is this clear? Sidra, Iram, Ahmed. चलो नेक्स्ट टाइम अब मंडे को कंटिन्यू करेंगे, ठीक है, ऑर्गेनिक से, ठीक है.